This is my 4-corner scale for RC cars, or you can use 3 load cells for an airplane. Each load cell's 5 kilogram capability, so you could do up to 20 kilograms total, as long as you don't exceed. Here we have a voltage monitor from the battery input. The wheel distance here is actually for airplane CG. I'll get to that in a minute. You've got front left, front right, rear left, and rear right. Percentage between front left and right, and percentage between rear left and right. And then the total weight. And then if you're using airplane mode, this would be CG. Bluetooth app seems to be the best to emulate the COM port. Open the app, connect. If you type in ME, you can get the menu at any time. Z is for re-zeroing. C1 is to calibrate the one load cell, so on and so on. W is to set the distance between the wheel sets. If you type in S, it turns on the serial monitor where it just cranks out each load cell value. They're all reading 0 right now, but that's why it looks that way. So I've just changed the mode to car mode, so now you get a front to rear percentage distribution, and here's what that looks like. Okay, my car's up there, and you can see I have about 3.210 kilogram, or 3,210 grams. The front left is 728 grams, 48% to the right, or the left distribution. Let's see if we can settle it a little bit here. Yeah, there we go. And then front to rear distribution is 47 front, 52 rear. You can make adjustments or whatever to the vehicle to get this perfect for you. For calibration, I just use a block of steel. It's 205 grams, and we just set that on top of the load cell and calibrate it. I'll show you the calibration sequence. So here we have the menu. We type C1 in, and that calibrates the first load cell. It asks you to 0 the load cell, so type Z. Then it asks you to put on the known weight, whatever your known weight is. Mine happens to be 2005. Type that in, hit enter, and then it asks you, do you want to save to EEPROM? You can say yes or no. So after that calibration, so you have the weight on there, and it reads front left 2005, which is correct. And I did calibrate that weight at work with a precision scale. Okay, this will be a demonstration of getting the CG and balance of a 3-wheeled airplane. You could have a tail dragger if you wanted. This works the same way. In this case, I'm only going to use 3 load cells. Each one has these little round pucks on there to center the wheels. And you can see they read about 2 grams more, so we're going to have to 0 it, and that's done with the Bluetooth. Back at the app, the menu, type Z, and it should 0. Okay, now that I've zeroed it, you can see everything's reading 0, and we're going to have to also change it back to airplane mode. Okay, now we need to set the distance between the front landing gear here and the rear landing gear here. So it looks like 364 millimeter. I'll set that in Bluetooth. Type W, and then type in the distance, 364, enter. And that's it. So now we have a wheel distance of 364, and we'll put the airplane on and you'll see the center of gravity. Okay, there's my airplane sitting in the cups, and so everything's centered. And now we can see that the weight is 1686, the front is 173, and front right is 0 because it's not reading anything. Rear left and rear right, so it's a little bit, let's see, heavy on the right side, but that's okay. And then the CG says it is 326.6 millimeters from the front wheel here. So let's measure back approximately. This is just for demonstration anyway. 326. Oh, look at that. So 326 is just a hair back behind that, so it's nose heavy. Correction, 326 is behind the CG, so that makes it light in the nose. I'd have to move the battery forward to get that to balance, so it's tail heavy right now. A little detail on the box itself. It uses I2C 20x4 display, LCD display, standard battery connector, anything 2-cell should work there. And then I did key the front and rear. Has these 2 little pins for the front, and rear has a single pin, so you couldn't technically plug them in incorrectly. That'd be a problem for calibration. The memory inside keeps the last known calibration if you use the EEPROM mode, which I don't know why you wouldn't, but it is an option to turn off. And then, of course, I have this storage platter here where each piece is labeled right, left, or rear, left, I'm sorry. That snaps in there. And then the display snaps in there, so all the pieces snap in there pretty good and gives you a little carry-in tray. Okay, let's go through the sketch. This was originally done by this person, Olav. He did a CG machine for small airplane, like gliders. And I've taken that information and modified it for the 4 load cells. There's also an airplane one I've modified as well to add the Bluetooth. But this is basically using an Arduino Mega for the reason this software or the firmware is a little memory intensive. A Nano or Pro Mini can't handle it. And then it uses a Bluetooth module. And for 5 kg load cells for a total of 20 kg for an RC car and 15 kg for an RC airplane if you're using 3-wheel. There's a menu built in the Bluetooth or the serial here. All the menu choices, S toggles on and off the serial monitor to see the weight and the distributions and things on the serial monitor instead of the LCD or with the LCD display. Calibrations are C1, 2, 3, and 4 for each load cell. Battery calibration or manually inputting the calibration using M1, M2, M3, and 4. ME shows the menu at any time. MO toggles between airplane mode and car mode. W sets the distance between the front and the rear wheels for the airplane mode. The memory allocations are here for load cell 1, 2, 3, and 4. That's what this section is. This is setting up the load cells and the HX 7100 or 71 or 711. I'm sorry, and there's 4 of them, so we're making an object for each one. Here, the LCD length, in this case it's 20. If you're using a 16 by 2, it'd be 16, but you'd have to modify the sketch a bit for that. Some of the setup, it's printing the menu, Bluetooth menu, yada yada. I won't go over the whole sketch below, but you can browse through it yourself. But basically it's looking to see if any of the, in the loop, if any of the weights are updated. Then it gets displays the weight. Then if serial 2 is available, which happens to be the Bluetooth input, it will handle the Bluetooth serial input. If the serial is available, which is regular serial monitor here on COM 3 or 4 or 5, 6, 7, whatever you have, it'll handle the serial input for that. There's a display voltage command, and then if you use the 0 button and then flashing LED. So it goes through this sequence over and over and over, depending on what you choose down here. You can see this sketch is quite long. Again, I won't go through all the details, but I'll just scroll through and show you how long it is. And here's the rest of it. Calibration. Yeah, it's quite a bit, but mainly what you want to look at here is the config. Some information about the HX711 library. Some important things about the voltage divider. If you want more accuracy, just don't exceed the input voltage of 5 volts to the Arduino Mega. The Bluetooth module needs to be connected to the RxD pin, needs to be connected to pin 16, the TXD to pin 17. This is TX and RX2 on the Mega. You can also use like 18, 19 pair, or yeah, there's many additional COM ports. The address of your LCD screen, 0x27, is mine. Yours may differ, but they're usually pretty much the same. You uncomment this if you're using EEPROM, so I left it open. I'm not using a 0 button because you can 0 at any time using the Bluetooth module. I do use an LED, so you can uncomment that, or comment it out if you don't want to use the LED. Even if you don't use the LED and you don't comment it out, pin 13 blinks the internal LED, so it'll still work. There's just some low battery threshold. I set to 7 for my liking. That makes each cell 3.5, so they won't get below 3.3 or 3.4. The wheel distance is set to 300 in the firmware here, but that can be changed. 3,000 is divided by 10 to help with the decimals. So 3,000 equals 300. These are my current load cell factors that I just hand typed in, but that's where they'll start. If you and should get you close to the right calibration if you don't have a known, somewhere in the neighborhood of 400 basically, but you can see the difference, how each one can be different. This is the load cell print interval, so every basically 0.2 seconds, and this is the serial print interval every half a second. Those can be changed. The battery voltage factor, this is just the starting point until you calibrate, and then you go down here to the load cell pinouts. I kind of arranged these so they would be out of the way inside the box, so 28, 29, 30, and so on, all on the right or the far side of the Arduino, just to get your connector out of the way. A0 is the input, but you can use any input you want. That's analog. The 0 button I have going to pin 13 next, or pin 12 next to pin 13. That's just to make it easier to put a pin header together. This is user defined if you're using a special I2C. Okay, here's the wiring diagram, starting with the battery voltage input connector going to the on-off switch. Here's the voltage divider for your analog read for the battery, 4.7 k ohm and a 10 k ohm. It's important to put the 10 k ohm on the battery side and the 4.7 on the ground so you get the right voltage here. Here's the Bluetooth module that's connected to 1617. We have a LED with a resistor here. Note this resistor is got to be sized for your resistance, forward current, and 5 volts. So I didn't put a specific resistance there, but you'll have to maybe do a Google calculation or something. These two pins are common, and these two pins are common, so I just use the ground for this switch. And then we send ground to pin 12 to reset if you choose the optional tear. Again, you can use Z in the Bluetooth menu to tear at any time. The I2C 20x4 display is connected to pin 20 and 21, which is SDA and SCL on the Mega. Here's where I clustered all the connections for the HX711 just to keep it out of the way for some other pins inside the box. You've got your 5 kg load cells here, so it should map out like this. You could change this pin configuration any way you want. These HX711s pretty much can be assigned to any digital and analog pin actually. So that's the simple sketch. It looks like a lot of work going on down here, but it's actually pretty easy to build. Again, yeah, I'll put this on my site so you can download it, and I also PDF'd it in case you don't have PowerPoint. On to the bill of materials. Bill of materials is pretty straightforward. I just have mechanical parts up here, some screws, nuts. Carbon fiber tube is actually, I don't have a source for this, but I just happen to have a 4mm carbon fiber tube. You need 2 of them if you want to keep the front and back parallel to each other, and you would you need them for the distance if you're doing CG mode for the airplane. I am going to put the model in my Thingiverse so you can modify that 4mm hole if you wanted to make it 5 or whatever, something more common or something you have like a dowel rod or something. CG scale electronics and parts is here. Arduino. Now I'm using a version 3 Arduino, which I found that some of the Arduino footprints aren't exactly the same, and the hole patterns are slightly off, so be aware that you may have to modify the model to get that Arduino Mega to fit just right. The HX711 modules should be the red ones as shown down here. Load cells 5 kg. Now you can bump up to the 10 kg, but you won't get as much accuracy if depending on how big your weight is. Resistors, just find them anywhere. Toggle switch, Amazon, same thing. DuPont connectors, I like the kits, and you might have to get a crimper as well if you don't have one. The JST-HX, I like to have a kit of those too, so I have that. The display, ribbon cable, I made mine really long because I have a few big airplanes that are tail draggers where the wheels are real far apart. And then lastly, the Bluetooth module. I got this off of Amazon, and it works with iPhones, which iPhones are notorious for blocking things that don't have the proper security measures. So that's it for the bill of materials.